My name is Brooke Heffright. I am the director of the CINA Center at George Mason University, and I am very happy to welcome you to our talk today. The title is An Architectural Model of Web-Based Technologies to Enhance Text-Image Capabilities in Detecting Sex Trafficking Cases. And our presenter today will be Professor Sambit Bhattacharya, Professor in Computer Science and Director of the Intelligence Systems Lab at Fayetteville State University. His co-PI is Professor Shamal Das, Professor of Homeland Security and Sociology, Elizabeth City State University. Dr. Das also serves as the Assessment and Program Coordinator of Sociology at the Department of Social Sciences. So before we turn it over to Sambit, I'd like to say a couple of words about CINA. CINA is a DHS Center of Excellence hosted here at George Mason University. It stands for Criminal Investigations and Network Analysis. Our mandate as a DHS Center of Excellence is to support the Homeland Security enterprise in countering transnational organized crime. DHS Centers of Excellence are managed by the DHS Science and Technology Directorate's Office of University Programs to conduct groundbreaking research resulting in rigorous, objective knowledge products and timely solutions for DHS components. Concretely, what that means is that every year George Mason receives funding from OUP to fund research by scholars at institutions all over the country, and in several cases in allied countries. And Dr. Sambit's research today was funded through this cooperative agreement. The challenge areas in CINA's research portfolios are criminal network analysis, dynamic patterns of criminal activity, forensics, and that includes both cyber and traditional forensics, and criminal investigative processes. And Dr. Sambit and Das's work falls into the area of both criminal investigative processes and digital evidence. Now, CINA's mandate also includes conducting education workforce development activities. For example, we participate in DHS's Summer Research Team project together with ORISE. Last year, we hosted 3 teams from institutions around the country, each partnered up with a mentor here at George Mason. We anticipate doing the same this summer. CINA also, with DHS's support, supports interns at components, and we're looking at our biggest year with a class of about 12 interns placed primarily with our two close partners, the Cybercrime Center here in Fairfax, Virginia, under HSI, and CBP's National Targeting Center. If you're at a component, we are late in the season, but we are always eager to hear from components who are interested in internship placements. So please feel free to reach out. CINA it also hosts events, and we conduct outreach. Our ongoing Distinguished Speaker Series will have our next speaker on the 11th of March. It'll be Colton Seal, founder and principal consultant at Pyxis Academy, with a talk on interviewer mindset. And we are proud to present that jointly with FBI's High Value Detainee Interrogation Group, part of a growing partnership. And on the 26th of March, we'll welcome David Mayman, one of CINA's researchers. He's professor and director of evidence-based cybersecurity research group in the Department of Criminal Justice and Criminology at Georgia State University. He'll speak on exploring evidence-based cybercrime research, and we are presenting that jointly in a hybrid format, both in person, online as a webinar, and as a podcast with the Sycamore Institute, the first 501c3 foreign policy focused and national security focused think tank run entirely by college undergraduates. So we're really pleased to be working so closely with undergraduate students and exciting them about careers in the Homeland Security enterprise. For information about any of our activities, best way to be in the know is to join our mailing list on our website at cina.gmu.edu. That's CINA with a C. We have a tab where you can sign up, indicate your areas of interest, and we will get the word out to you. CINA is supported by a DHS board of directors, many of whom are on the call today. They help us to ensure the relevance of our research and identify champions and funding for transition. And in that respect, CINA, in addition to our cooperative agreement with DHS, has a basic ordering agreement under which DHS components can write task orders on a non-compete basis. It was recently renewed for 5 years, and it can facilitate transition and bespoke research. If you're interested, our transition and impact manager, Steve Self, can help to set you up. Now, with preliminaries out of the way, I'd like to turn it over to our speakers, Dr. Sambit Bhattacharya from Fayetteville State University, working closely with, jointly with Professor Shamal Das at Elizabeth City State University. And the talk, once again, is an architectural model for web-based technologies to enhance text-image capabilities in detecting sex trafficking cases. And I'll ask you to save your questions till the end, because we record the talks, but not the questions, to allow our government folks, government partners to speak more freely. When we get to question time, I'll ask you to put your questions in the chat, and I will moderate and read them off to Sambit so that he doesn't have to watch the chat while he's answering. All right, Sambit, please take it away.
Thank you so much, Brooke. So let me start by sharing my screen. Are you able to see this?
Yes.
All right. Good afternoon, everyone. It is a pleasure to be able to deliver this final briefing for our project. And you've heard from Brooke the long title of the project. And let me introduce once again Dr. Shamal Das from Elizabeth City State University. He has actually joined the call, but he is not able to participate because he underwent surgery recently. He's still recovering from surgery. And I am Sambit Bhattacharya from computer science, professor of computer science at Fayetteville State University. So our partnership was mainly based on Shamal's expertise in social sciences, especially sex trafficking, and my research in AI, more on use-inspired AI research. So where we take use cases and we develop, basic research and turn them into applications. So we are very much, use case focused, and this was an excellent opportunity to do something that was very relevant and important. So we will discuss along the following lines: the research challenge, introduce the project and the technical approach. There is a fair amount of detail in my slides, and I will go through so that we can meet the time limitation for our project, for our presentation today. If you have any particular question about any of these technical approaches, more than happy to answer. We have comments about application and stakeholder engagement, which is kind of more future-looking, and transfer of tech and results. So, at a high level, from the AI side, let me say that I'm sure all of you know, and all of you are experiencing the tremendous breakthroughs in AI that we are going through right now. And AI, primarily, it has made breakthroughs in computer vision and natural language processing, which is how to perform human-level tasks on visual data and on natural language data, which could mean written text and speech and all of that. So this is, let's say, the AI research challenges that are actually being solved right now, and we see tremendous progress. And there's a space where you have multimodal AI, which is where AI takes data from different modes. Let's say visual data, language data, and maybe even audio data, or maybe other kinds of sensory data, and is able to perform human-level tasks, which we do actually being immersed in the real world. So that is the point of view from the AI world. But how do we apply this to a research challenge like detecting human trafficking on the web? Well, on the web, data shows up primarily on human trafficking cases as a trafficking ads, and these trafficking ads have visual elements along with text or written elements, which are natural language elements, mixed up, and they appear in very tremendous variety and forms. So our project attempts to use or apply these recent AI approaches to detect such trafficking ads. So this is what our project aim is, to improve the detection of trafficking ads, and by leveraging multiple open source programs and synthetic data sets. So these are two key things I want to just mention. Open source is important because we are leveraging open source models. We are not actually going through any proprietary models because that would introduce its own complexity. And then the synthetic data set part. Sometime, let's say a few months into the project, we realized that acquiring real data for solving this kind of a problem poses its own challenges. And that's why we pivoted to production of synthetic data. And production of synthetic data has also gained quite a bit of maturity because of generative AI. Generative AI is that type of AI which is able to generate hyper-realistic data in either in the text form or visual form. And so some of the most recent advances of AI are repackaging of those generative AI models. So we have used those models, or rather certain customized versions of these models, to generate synthetic data to be a proxy for real data, because acquiring real data was a challenge, and as you all know, making AI to work at a certain acceptable level of accuracy requires enormous amounts of data. So due to the lack of data, lack of availability of real data, we solved the problem with synthetic data as our proxy. So this approach enhances the detection capabilities of combining AI-driven text and image analysis to identify trafficking-related patterns online. So this is what we call the cross-modal retrieval, which is text plus image fusion. And this is what we're using to detect trafficking-related online advertisements. So another question is, how effective is really this synthetic data, and what are the limitations of synthetic data in replicating real-world trafficking patterns? So these were the research challenges that we went through. And this is pretty much the same project introduction that you've seen in the previous slide. So one thing I would like to point out or emphasize is that our attempt at creating synthetic data was not purely just for the sake of synthetic data, but it's really a method to fill gaps with real-world data sets. So it could be a proxy to a lack of real-world data, or there could be gaps in real-world data that you may want to fill up by using synthetic data. So this is a sort of a more detailed technical approach introduction. So our research integrates AI elements of social science to detect human trafficking online. So it's an integration of AI and social science research. So we developed an approach that analyzed web text-based text-image data using computer vision and generative AI models. Preliminary results show promise in identifying possible trafficking in related online advertisements. Now, I want to point out here that, again, due to lack of access to real data, we can't characterize how it actually performs on real data, but our results are mainly confined to the synthetic data domain. So this initiative aims to improve detection capabilities and focuses on victim-centered approach, and so on. So we are adopting or developing a cross-modal analysis approach. And let me point you to this diagram here, which shows you the more or less high-level picture or a schematic diagram of this model, or AI model, or algorithm, if you will. This is really a hybrid algorithm, because there are, technically speaking, AI models integrated with this entire process, but there are bits and pieces of code that glue together these models and send the output of one model to another model as its input, and so on. So there's a lot of complexity here, and this is really a simplified view. And if you look at the simplified view, input data comes in as the form of a mixed image or visual data and text. And this text data can be of different types. It could also have embedded emojis. That's a point we will come back to a little later in the talk. And then if you think of this as separate types of modalities, the image and text, they are being processed by their own AI models, or AI models which can ingest those specific types of modalities, and they're converting them to, let's say, more processed forms of of the same information. The technical term for this is feature vectors, and these feature vectors are combined in what is called the joint feature space to produce the classification output, which means, and these are numbers that are just representative of the kind of level of trafficking, let's say. So the output is, generally speaking, trafficking versus non-trafficking, but there are certain things that we also look at, which is data that seems to be about trafficking, but could be about escort ads, let's say. So which are, from our understanding, legal. So in that sense, we're also going into that sort of nuanced classification. In this case, the joint feature space is also outputted by a model which is able to process visual and text data jointly. So that is a clip type of model, which we'll come to later. So we explored all of those approaches. So let's answer the question, why synthetic data? So the synthetic data in form of text and images can support and extend real data sets. And they can evolve. Another benefit is they can evolve and be updated quicker to adapt to new trends. The AI-generated text and image data sets can mimic real ads quite well. And it's the ideal data set, it's continuously updated due to evolving online advertising tactics. And we can probably keep up with those new tactics by using synthetic data sets too. And there are some concerns, as always. Creating underage AI-generated images poses legal and ethical questions, definitely. And there is possible bias or misrepresentation by group or stereotyping. And the other thing, let me point out, is that using even open source models, you have to remove their guardrails, which is something we will come back to a little later, and that could pose its own challenges. Although we were not able to find any legal challenges to removing guardrails of open source models. So these are some examples, and we will now begin to look at examples, practical examples. So we used the NSFW, or Not Safe for Work detector. Now, this was an off-the-shelf model and classifier, which we were able to fine-tune with our own synthetic data. So there are different kinds. You have a detector and a classifier, and then a private detector, and then a clip detection model, which is capable of analyzing both images and text in combined form. These were the categories we fine-tuned to have that model detect, and we trained over. This is not we, but this NSFW model was actually trained over 60 gigs of labeled data. So these are some examples of synthetic data. These are not real, by the way. These are synthetic data, synthetic images, which were given to the NSFW detector, and this NSFW detector, after that level of fine-tuning which I was talking about, to make it perform better on synthetic data, because they were originally trained on real data, which we don't have access to. So that NSFW detector was able to give probability estimates under each category, as you can see overlaid on the images. These are, and I'm going to describe some of the other sources some of the sources that we used. So one was, as I was saying, the NSFW detector. It uses clip embeddings. Clip embeddings is actually a very well-known AI modeling approach, which is able to ingest data in visual and text or language features, and is able to give you probability scores based on what you wanted to detect. So this is what we did, and the NSFW detector, overall the model helped us doing these detections, like filtering images with scores of scores from 0 to 1. Actually, that's a typo there, and it helped us develop a concept for a fusion program which assesses the image scores from 0 to 1 based on the NSFW content. So the NSFW classifier detects images into categories, and these are some of the categories, as you can see. So neutral images are discarded while explicit images are triggered and subjected to further biometric analysis through another model called DeepFace. This is another off-the-shelf model model, which we were able to use successfully and actually fine-tune with our synthetic data. And this deep face model is able to detect certain characteristics. It's able to infer the age of the person, the gender of the person, and so on. And in fact, you're also able to detect the emotion content of the face that's there in the image. So the other sources that we used fall in the category of private detector, which actually detect exposure, skin exposure. With a probability value which indicates the lewdness of the content of the image, and this is where we can potentially link it to human trafficking, and the data set was used to classify images into lewd or non-lewd. So these are some of the outputs that we were successfully able to do using TensorFlow models. TensorFlow is this deep learning framework from Google, based on which we developed some code, and we also used PyTorch, which is another well-known industry AI framework and library. Then clip retrieval is, as I've discussed earlier, integration of image and text data, and we were able to successfully use clip retrieval to classify the entire image, entire ad content, which comes in the form of image and text. So looking at the deep face model, which I described earlier, the deep face is a lightweight face recognition and facial attribute analysis. And as I was telling you, it gives you attribute analysis such as age, gender, emotion, and race. And there are some interesting things that we found out. And the age, for example, is useful for estimating whether underage or not. Of course, this is definitely very important for our project. Race, you could say it's not particularly useful for our application, but we know that there are certain races that are more or less represented or overrepresented in trafficking image data sets. So this is where this could be an important attribute to measure. And emotion is another attribute. And we think, or we have heard from different conversations with stakeholders, that images show, or trafficking images show certain emotional content, which could also be important for the deep face analysis. But we were mainly looking at age, race, and gender for analysis, and we had some initial results from both real and synthetic data. Of course, the real data was not trafficking data; it was just face images that were available on the internet. We subjected it to test after fine-tuning, and we used this backend called Retina Face, and we had some successful or high performance rates. Some of the observations were that it had more difficulty predicting accurate ages with younger subjects. So when you have younger subjects, let's say 18 or below, and even older subjects, the accuracy of age prediction or age detection, age inference, whichever way you want to call it, seems to decrease. So, and there is a class confusion between races, and that is, I think, quite natural, because for us humans also, we sometimes, are not able to identify a race or even an age of a person based on just the image. So, what is the role that text classification plays in the detection? So we adopted a few approaches: analysis of keywords, phrases, and linguistic patterns in online ads. Helped distinguish between trafficking related and benign or non-trafficking related situations, such as independent discourse. And then we assessed at a high level the accuracy and capability of these tools. And we also assessed the role of the lexicon in the detection process. So we used a predefined keyword list, coded language list, emojis, and euphemisms used in trafficking ads. We actually had a whole list of those in our database, from which we used generative AI, as we will see later. And we were able to do context-aware word selection to enhance the precision and reduce false positives. So the challenge and limitations we observed are that evoking trafficking language makes static keyword lists ineffective as time passes, because the lexicon or the vocabulary and the linguistic patterns do change over time. And there's context ambiguity. And there's potential enhancement the potential enhancement is to improve cross-modal retrieval. So where the text is ambiguous, maybe facial recognition or scene environment context would be more successful in detecting the ad as a whole, or detecting the ad as a trafficking ad as a whole. And that's why we feel this multimodal approach is an improvement over just purely based on text or image. So other approaches, technical approaches that we developed was emoji analysis, and we know that emojis are sort of have a lot of semantic content in text. So when they're embedded into text, they have certain kinds of meaning. And so we know that emoji patterns exist in escort ads, and they may be used to indicate underage or trafficked victims. So they could be used to signal key attributes like age, availability, and location. And we actually have a certain keyword, or not keyword, but emoji detector and classified models within our hybrid approach. So how did we get those emojis or emojis embedded in text? We actually used large language models to generate these synthetic ads, and that incorporated the images. And we developed a set of lexicon of traffic associated emojis for classification. So this is like a cherry emoji may indicate a victim that may be underage. Now, this was all done with our research expertise in sex trafficking, which Dr. Das's specialty. So this was an excellent approach where we had the social science domain knowledge integrated with the AI or AI development. So we explored combining emoji-used insights with image-based AI and biometric analysis for stronger detection. Now, as we have said before, we are completely using synthetic data. So synthetic text ads is what we worked on. And so synthetic text data is not just needed by itself, but it has to be associated with the image prompt, because I mean, we want to create synthetic ads which are text and image combined. So generative AI is known to have guardrails which prevents NSFW generation. We know that generative AI prevents you or says that, hey, I cannot do that because what you're asking me to do is NSFW, and it may be illegal, and it is both for images and for text. So we happen to use some downloaded local versions of LLMs to use prohibited words. And so some image generators actually specialize in nude content also, but not for text generation. We also experimented with those. And so we actually did a lot of experiments by omitting phrases or keywords. And we figured out the best combination that would give us synthetic data, which would be close to trafficking ads. So here is one successful approach that we adopted for Meta's Llama. I don't know if there are many large language models available now, but Meta's Llama is one of those large language models that are open sourced and available for download. So there is a process by which you can obliterate or uncensor LLMs without retraining. So since these are open source downloadable LLMs, you can actually retrain them or fine tune them to do certain things that they were not initially designed to do, or to obliterate or remove barriers such as guardrails. So we were able to do that even without retraining or fine-tuning, because obliteration is a process that we studied, and we adopted that from the current literature on LLMs. And this is the process. If you're interested in it, this is how obliteration is done. Obliteration is basically the removal of filtering mechanisms at the output layer of your large language model. So it turns out there are certain things called rejection vectors, and a rejection vector means when your prompt, which is producing the final output, let's say, and if your output vector is anywhere close to this rejection vector, it will get rejected with high probability. So if you can suppress this rejection vector, then it turns out you can have it generate things which it was prevented from doing due to guardrails. So here's an example of successful guardrail removal through this process. And again, the reason why we did this was to generate close to real trafficking ads. So synthetic images are, of course, as we said, since these are whole ads we're looking at, and then the synthetic image generation poses another type of problem, which is generative AI has guardrails implemented that prevent us from generating such synthetic data. But there are some models online which you can use to generate synthetic data of the NSFW type. And then we also developed some approaches on age validation. And previously, remember that we said that DeepFace has a problem with age. It is not able to identify certain age categories, let's say below 18 or much older people. It is not able to detect that more or less accurately. So we developed another approach where we are able to plant the face of a person who has a known age onto a synthetic data. So if you think of this example here, you're barely able to see the difference between the woman on the left-hand side and the picture of the woman on the right-hand side, but there are indeed differences if you look at it carefully. So what's going on here is that the face, which is, by the way, the image on the left is a synthetic image. The face of this synthetic image has been replaced by the face of a person from this photograph. And let's just say that the person in the middle that you see has a known age, a verifiably known age. Then you can actually do this to produce multiple synthetic data items where we know what the age of the person is based on their face. So here we tried this to fine-tune our DeepFace model to be better at age detection. So then we were able to use a combination of Stable Diffusion and ControlNet. So Stable Diffusion is the generative AI model, which is able to generate images given text prompts. Now, ControlNet is what allows us to have control over what is being generated. Because when you do a prompt, let's say if you look at these images on the top, there are, even after removing the guardrails, and then you have a prompt which generates such an image, but then you cannot control the kind of pose or the location of the person that is being seen in the image. ControlNet allows you to do that to a certain extent. And there are ControlNet functionalities like canny edge detector, based on which it detects edges of objects in the original image, and it's able to literally paint pixels within those edges to form the impression of another person, totally with that same shape and pose, which is quite interesting. And then Open Pose, where you have the skeletal overlay of a detected image input subject, and using that skeletal pose, you can generate let's say a totally new person with the same pose. So these are approaches that we worked on. And if you look at this two images at the bottom, this woman and that woman here have the same pose. But if you think of this as this was actually a real image, I think, and that's why her face is erased, and the surroundings, there's a high degree of similarity between the person's pose and in the real image and the synthetic image. So this is, by the way, on the right-hand side of the synthetic image, and you see the objects and the general layout of the room is pretty much the same, but the look and the type of objects are different, and the person, of course, is totally different. So here, what we're seeing is that we can take the organization of an image, the pose of the people in the image, and the objects in the image, and can produce an entirely new image, and an entirely synthetic new image with the same pose and same types of objects in general, but which would be different from the original image. So this gives us a way to produce enormous amounts of synthetic data with control. So this is we were able to do this towards the last stages of the project, and with this we can produce enormous amounts of synthetic data with a lot of control. So then we also use the Flux1.1 model, and this gives us the ability to do OCR on extracted text. So if you have, let's say, an ad shown within the image, let's say a telephone number, let's say the victim is holding up a card with a telephone number, call me or something like that, then you can detect with OCR the content, the OCR, the text content of the image, and then you can extract the secret phone number, if you will. So, which are obviously we cannot process with a natural language processing program. What you're doing is text extraction from images. Now, ideogram is another very recent open source state-of-the-art model, which enables us to generate captions to describe what's in an image. So with ideogram, what you can now do is generate the caption of an image. Caption is basically a language description of the image done by AI. So the AI ingests an image and produces the language description of the image in a sentence or two. And then what you have essentially is a language description of the original image or the real image. And using that, you can now prompt your AI to generate many, many synthetic images of the same kind using that same that caption as the prompt. So that's what we did. So these are different ways of generating synthetic data sets. And in the text generation, and here I don't need to go through too much detail here, but there are certain approaches that we developed on top of the llama model, which are able to, after doing the obliteration or the obliteration, we were able to generate trafficking and non-trafficking style text ads. And we were able to embed attributes like age, hair color, emojis, coded language. And this ensures the real world ad diversity. And this is basically the overall text generation strategy as shown as a flow chart. So there were some failure rates due to hallucination, and please note that this is not a perfect process because generative AI is still very statistical, and it hallucinates. You may have heard of this term when hallucination means basically getting things wrong in the final output. When you give it a prompt and you want some kind of output, it is not just the far from the output or what you intended, but it could be completely wrong. So there is a certain error rate due to this, and therefore, if you want to use synthetic data and generate synthetic data with such combination of processes, then there is a certain human oversight or data cleaning that you still need to do. So we were able to, and this is really the wrap up of the technical approach that I described, and we were able to incorporate key attributes in the images through the processes that I just described, using generative AI and or stable diffusion and control net, and we were able to control things like poses, lighting, environment, and key attributes. So these are some details which really helped us producing very real images. So overall, this is the workflow. And the text ad generator, it could be given quick facts, would be given quick facts like these in a structured form. And then it would certain facts would be given to the text generator and would produce the text ad, which looks like this, which has embedded emojis, as you can see. And we found out that it was able to produce quite relevant or meaningful emojis that had to do with the text content. And then the Flux AI image generator, with that, we have a lot of control about the content of the image. For example, if you look at this woman, she's holding up a card which has a phone number, flipped over. So the text is flipped. So we can do all these variations and interesting different generations, and we can use, by the way, same person, literally the same person in different poses due to control net. So we can have the person visualized in different environments, as you can see in a hotel or some other environment. So text classification and then the fusion program, that's what we'll look at now. The text classification was done through a few shot training on the LLM, the Llama LLM. And this is, few shot really means you give it a few examples of what's a trafficking ad and what's not a trafficking ad. And that gives it an insight into what it means to be a trafficking ad and what's not a trafficking ad. And based on that, it's able to classify future unseen examples into trafficking versus non-trafficking. And with this, we were able to get high accuracy with a validation set. And then this fusion program, this final fusion program utilized a decision tree structure based on various libraries to determine whether that was a trafficking ad or not, overall looking at the image and the text part of the image. So this is the fusion process, the text ad generator, the image generation with the control net, and the ad was passed as a combination of text and image data, and the analysis came out like this. So the analysis comes out like this through this decision tree approach at the final end of the hybrid algorithm, and this decision tree is able to give you different types of attributes, such as age, range, and emotion for the image, and trafficking score for the image, and the caption for the image. And so this is really really a caption generated based on the image content when you show the image to the caption generating AI. And it's able to actually, as you can see, it is able to do OCR on the image and tell you what kind of text data, or let's say written information, is embedded in the image. So it's able to do OCR and, let's say, extract things like a phone number embedded in the image. So it's able to give you total image score finally, and some ambiguity score based on all of these characteristics. So now we are approaching the end of the presentation, and this is the wrap up. And so we explored the benefits of this template-based prompts for LLMs and creating synthetic data sets. And we believe that stakeholders such as law enforcement and Homeland Security personnel would benefit from implementing these techniques and strategies presented in this research at scale. So what we're trying to say here is that where you have changes in how these trafficking ads are showing up in the real world, and you don't have enough of that data, or it's difficult to capture that data in great quantities, and if you only have a few samples, maybe this could be a very useful approach to generate more and more data, which are synthetic data, which are very close to the real type of data that is generating right now, that is being generated right now, that you're capturing right now. So this can give you a way to increase your data size and train an AI model to be performant on the new types of data that you're seeing. So these are the results. There is definitely room for success. And we achieved high accuracy in synthetic data sets, and in deep face analysis, and lexicon and emoji detection. And then the emotion detection is part of a thing which is we had to do it independently, because we are not quite sure how that impacts the detection of whether the ad is a trafficking ad or not. And then the fusion model, we gave it the final fusion model. The fusion model is able to give you a final output of a likelihood score. So note that the real world validation is still missing, because this work is done entirely on synthetic data. And that is our final comment here. So this is our key findings. We feel that multimodal AI models can improve trafficking detection. Lexicon and emoji analysis can enhance pattern recognition in online advertisements. Synthetic data set generation can provide realistic training sets, but it does have accuracy and ethical challenges. And the challenges are also may lack emotional depth or inaccurate ages. And there is need to validate key attributes such as age or for the images generated. And then using real data sets to validate or enhance synthetic data sets is critical to determine usability. So future directions and takeaways, we developed AI models and techniques which should be adaptive and evolve with which we should be able to adapt and evolve to real world trafficking patterns. And that is my final comment, really, because I feel that the use of the process we have developed for generating synthetic data and using that to train AI or our fusion model is a critical capability, because that will let us identify new trafficking patterns and generate more synthetic data based on a few samples of these patterns, and thus have a sufficient data size to be able to train our fusion model. And so we look forward to tech transfer of the results. And at this time, I would like to point out that other than the slides, I do have a document for code delivery. And this code delivery has links to Python notebooks, which are Colab notebooks. And I'm going to show you some of my tabs here on my browser, and these tabs show you different programs that we have developed. These are Colab notebooks that will directly run on your browser. You may know a few things. A little bit of training may be needed, but this is overall, here you will not need any coding or computer science expertise just to run this code. This is set up in such a way. These are Python notebooks, and so these implement different functionalities. For example, trafficking text ad generator, as you can see from the title, and these are all cloud-based, so you don't need to install anything on your machine, and these will run directly on the Google Colab, which is hosted on the Google Cloud, somewhere in the Google Cloud, and versus trafficking text ad generator versus non-trafficking text ad generator, which is useful for training our classifier. And then you have the automated image analysis models. I don't have all of these Colabs open up here because, and then you have all of these links here, which we can pass on if anyone wants to use them. So this brings me to the end of my presentation. I think we're doing good on time, and we can do question answer.
Great, Sambit, thank you very much. What a fascinating and detailed project. So many terrific deliverables, and I think that your transition tools and products are kind of best in class. Really great best practice to allow folks to try out this technology without facing some of the technology hurdles involved with technology until they're sure that it works. So great. I'd like to open it up to questions. Anybody in the audience? We don't have anything in the chat yet. Like I suggested at the beginning, we could pop questions in the chat. I'd be happy to read them off. To kick things off, I'll ask the first question. Oh, yeah. So Richard asks for a copy of the slideshow. We will absolutely send you a copy of the slideshow to all participants after the event. Okay, I'll ask the first question. The approach integrates computer vision and generative AI models to analyze web text image data. So could you elaborate on how your system handles the challenge of detecting subtle trafficking indicators that might intentionally be disguised to evade detection, especially as traffickers adapt their tactics in response to increased monitoring?
Absolutely. So we have discovered methods for generative AI prompting, whereby you can produce certain special effects in the generated image, or the fake image, that is, or synthetic image, if you want to call it that. So we can produce effects like tattoos, certain kinds of tattoos on the body or certain locations of the body. And I believe through our discussions with stakeholders that tattoos are important, data points or indicators of trafficking, or indicators. I'm sorry, I shouldn't have said data points, but indicators of trafficking in the image. So we were able to successfully produce certain types of tattoos on certain locations. We were able to control those locations actually through prompting. And you may have heard of prompt engineering quite a bit when it comes up always with generative AI, because that's how you make generative AI do its thing. So prompt engineering, even though it seems simple, there are many things that have to be known. You have to know it in advance how to do it to produce those effects in the generated data. So that's what we discovered through mainly experimentation and reading the literature, how with more effective prompt engineering we can produce effects like this, like let's say a tattoo or a written piece of text within a card that the person is holding up in the image. Because that's another thing that we were told that frequently happens. The victim shows a card which has some kind of secret code. So producing that within the image with the precision of the person holding up that card, that requires some level of prompt engineering. And if you want to do it at scale, you have to develop some programmatic ways to, send API calls to your generative AI model, and just to automate that and to scale up the production process with many variations, with many realistic variations.
Great. And I'll emphasize to folks who are not as familiar with CINA that the terms of our cooperative agreement prohibit the sharing of data between DHS and our researchers, and that's to create a very clear line between law enforcement and research. Very, very appropriate in the cooperative agreement, but we are able to do closer collaborations between DHS and researchers on a contractual basis under our basic ordering agreement. So if that's something that you're interested in taking this one step forward with the researchers, we would be happy to set up a bespoke briefing to talk about funding for onward research.
Thank you, Brooke. I'm most interested in that, if you want to take that step.
Great. So we have a question here from Gabriel Martinez. Is your work set to be used for missing persons with age adjustments? I understand that minors can be kidnapped, forced into sex trafficking. You may have already addressed this topic. So I think what this addresses the problem that we may have an image of a person at one age, and several years later they're likely to look very different.
Exactly. That's a great question. So I've seen a recent literature that shows the generative AI is also able to age a person according to certain characteristics. So again, that goes into some careful prompt engineering and also some model level modifications that you need to do, or fine tuning you need to do to let's say the process is at a high level, you input the image of a person at a certain age, and then you need to ask the model to show this person at, let's say, 10 years plus from that age. And that seems to be working well. But then you could also do certain things like maybe this person suffered from disease condition through these years, certain kind of disease condition. It is quite incredible that it's started to work at a certain level. And I can point you to that literature. I don't have it ready with me, but there's literature that shows, just through enormous amounts of data sets where you can show the person at the certain age and the next one, all these real images, you can actually not only just age a person, but also tell the AI what conditions they may have suffered from to get to that age, or while getting to that age, and the AI is able to somehow incorporate that information.
Wow, fascinating. Yeah. Great. I'll ask another question. Synthetic data offers clear advantages for training and testing, but how do you ensure that your models trained on synthetic data will generalize effectively to real-world trafficking advertisements, particularly given the constantly evolving nature of online trafficking tactics?
Excellent. So there are methods to quantify the difference or the gap between a simulation and real. That's called the sim to real gap. And that actually, the sim to real gap is discussed in many different contexts in the literature. But when it comes to images, it means something which is specific to images. That is, what is the gap between synthetic data of a certain kind and real data of that kind. So let's say if you just want to use an example, pictures of mountains, right? Mountains that we see in the real world and synthetic data on mountains or synthetic images of mountains in the world. Can we quantify that difference? Yes, there are methods to quantify that difference. In this particular case, those methods can be applied if we have access to real data, or whoever has access to real data and synthetic data, parallel data sets, which are similar in a semantic sense. So I said, mountains and mountains in the synthetic data. There has to be some semantic similarities, some meaningful similarities. Otherwise, the difference cannot be measured accurately, right? So, and furthermore, you have to say more things like mountains in daytime, right? In a clear sky, with the sun on the sky, something like that. Now, if you get into more details, then you can actually match a corresponding real image with a corresponding, a real image with a corresponding synthetic image of that kind, and then your sim to real gap measurement becomes more accurate. So yes, you can do that for trafficking ads, absolutely. That means you need to have access to synthetic data and parallel or corresponding real data.
Great, thank you. Any more questions from the audience? Okay, well, we have time for one more question, so I'll ask it. Given the sensitive ethical considerations, how does your team balance the need for accurate detection with potential false positives that could impact legitimate service providers? How do you incorporate feedback from law enforcement and victim advocacy groups to refine your approach? I'm sure there are some audience members who are particularly interested in
that. So we have had discussions with stakeholders as to how we can get access to some kind of real data or have testers within secure environments test our models. So one way to do this is to test our models in a secure environment, right? Where you have real data in a secure environment. And we want to, or rather, I think this is the first step. For example, the one that I'm showing you, in notebooks, these notebooks can be run locally. You don't have to run it on the Google Colab, or which is on the Google Cloud. You can actually run this locally if you have some type of software which is able to support Jupyter Notebooks execution. You can have it run locally, and therefore you don't need to send your secure data to the cloud, and actually can test this. So I would say the results we have collected, the code we have collected, is a somewhat of a step in the direction of having actual people who work with this data use this and find out what are the false positives, what are the problems which need to be addressed in our research or the results that we have produced. So yes, this is one step along the way. We can actually give you the code and give you some maybe instructions on how to have this run in a secure environment. We can work with you.
Right, and CINA stands ready to facilitate that. We can, set up a private conversation, one-on-one conversation, and put you in as close touch with the PI team as possible. And if you're interested in supporting further research to adapt this technology to your platforms and to your workflow, we'd love to be part of that. So with that, Sambit, I will say thank you. This has been a great presentation, and thank you to everybody who's joined us. Like I said at the beginning, we have recorded this talk, and so we'll be putting it up online. If you enjoyed it, feel free to, and please do share it with your colleagues within the Homeland Security enterprise. And with that, I'll say have a great afternoon.